In this section, we're going to look at compositions. Compositions is a way to put two functions together. The composition sign is a small circle that looks like a degree mark, except for it's written halfway in between the letters. F composed with g of x really means f of g of x, and g composed with f of x means g of f of x. Whichever letter comes first will always go on the outside. Whichever letter comes second will always go on the inside. You will sometimes see just shorthand notation for f composed with g or g composed with f, but these mean the same as the definition, f of g of x or g of f of x. Steps for compositions are as follows. You want to write the definition. You're going to replace the inside function. Then you're going to write the outside function, omitting the x, using an open parentheses in its place instead of the x, and fill in that open parentheses with the inner function, or what's inside the square parentheses, from the step above, and clean up. Basically, the inside function is going to become the x for the outside function. Let's look at an example. If we have f of x equals 3x minus 2 and g of x equals 4x plus 8, f composed with g of x means f goes on the outside and g goes on the inside. We are going to use an x. After we write that definition, we're going to replace the inside function. The inside function is g of x, so I'm going to, instead of g of x, rewrite that as just 4x plus 8. The 4x plus 8 becomes the x for the outside function of f. Well, the f function tells us to take 3 times our x minus 2. Notice I didn't write the x, I used an open parentheses because I'm going to fill in that x with my new x of 4x plus 8. At this point, it's just a cleanup. We say 3 times 4x is 12x, 3 times 8 is a positive 24, minus 2, and combining like terms for 12x plus 22. If we take this backwards, g composed with f of x means g is on the outside and f is on the inside. We're going to replace that inside function. How it's defined, f of x is 3x minus 2, so I'm going to write 3x minus 2, and that's going to become my x for the g function. The g function tells me to take 4 times my x and add 8 to it. The x that I actually use is going to be the 3x minus 2. And at that point, I'm just going to clean up. 4 times 3x is 12x. 4 times negative 2 is a negative 8, plus 8, or just a plain 12x. Notice f composed with g and g composed with f gave us two different answers. They are not commutative, meaning the order is going to matter in these problems. Let's look at two different functions, f of x equaling 3x minus 1 and g of x being x squared. If we're going to look at f composed with g of x, that means we want f on the outside and g on the inside. We're going to replace the inside function. Instead of g of x, we're going to write x squared, and now x squared becomes the x for the outside function of f. The outside function of f tells us to take 3 times whatever the x is and subtract 1. We'll fill in our x with the x squared and just clean up. 3 times x squared minus 1 is 3x squared minus 1. Going backwards, the g composed with f of x will give us a different answer because the g is on the outside and the f is on the inside. You're going to replace the inside function. So in this case, instead of the f of x, we're going to replace it with how f of x was defined as 3x minus 1. And that becomes the x for the g function. The g function tells us to take our x and raise it to the second power. And the x that we're actually going to raise to the second power is the binomial of 3x minus 1. Now we need to clean that up. 3x minus 1 squared really means 3x minus 1 times 3x minus 1. Use your distributive property or FOIL for 9x squared. Outer terms are negative 3x. Inner terms are negative 3x. Last terms are going to give us a positive 1 when we multiply. We're cleaning up for 9x squared minus 6x plus 1. Let's look at one more example and then we'll use some numbers. In this example, if we were going to do f composed with g, that means the f is on the outside, the g is on the inside. We're going to replace the inside function. The g of x is the same as the square root of x. And now the square root of x becomes the x that we actually use in the f function. The f function says 2 minus 3 times my x, which is now the square root of x. Cleaning that up, that's just going to be 2 minus 3 times the square root of x. Backwards, g composed with f of x means g is on the outside and f is on the inside. We replace the inside function. F of x is 2 minus 3x, and that becomes the x for the outside function. The outside function tells us to take the square root of our x, and our x in this case is going to be the 2 minus 3x. Now let's look at these functions again, and instead of composing with x, let's compose with a number. Going back to our first example, if we say that f of x was 3x minus 2, and g of x is 4x plus 8, if we wanted to look at f composed with g of the number 5, that definition means f goes on the outside, g is on the inside. Instead of using x, we're going to use a number 5. So we replace the inside function. We're going to go to the g function and use a 5. Instead of 4x plus 8, we're going to have 4 times 5 plus 8. Now let's clean that up. 4 times 5 is 20, plus 8 is going to give us 28. 28 is going to be the number that we use for the x in the f function. Our f function says take 3 times our x, which is 28, and subtract 2. Multiply 3 times 28, and that should give you 84 minus 2, or just 82. Likewise, we can go backwards. Let's look at g composed with f of the number 0, or g on the outside, f on the inside, use a 0. Replacing the inside function, go to the f function, plug in a 0. Instead of 3 times x minus 2, we'll now have 3 times 0 minus 2. Well, 3 times 0 minus 2 is just going to be 0 minus 2, or a negative 2. So now we use the negative 2 in the g function, which tells us take 4 times our x, which is negative 2, plus 8. Well, negative 8 plus 8 is just going to give us the value of 0. So plugging in with numbers is not going to be very difficult. Let's also talk about the domains of these functions. If we look at our next example, the domain of f of x, because we don't see any fractions or any even-indexed radicals, is going to be the real numbers, or an interval notation from negative infinity to positive infinity. The domain of g of x, also because we don't have any fractions or even-indexed radicals, starts off being all real numbers, negative infinity to positive infinity. When we look at the composition, our final answer has no fractions, no even-indexed radicals. So the domain of the composition, or what we can use for the x's, would be all real numbers. And g composed with f, no fractions, no even-indexed radicals. So again, our domain would be all real numbers. We'll see a little bit of difference in this next problem. When we started off with f of x equals 2 minus 3x, we notice right off that the domain is all real numbers. We can use whatever we want for the x in that case. But in g of x, we've got a problem. We've got an even-indexed radical. Because we have the even-indexed radical, the radicand, or what's inside, has to be greater than or equal to 0. Or that's going to be from 0 to infinity. So if we look at the composition, f composed with g, notice we're starting off, the g of x, or the square root of x, is going to be 0 to infinity. So since we're using that, the domain of the composition, again, is going to be from 0 to infinity. In our g composed with f, We start off on the inside using all real numbers, but after we finish that function, the 2 minus 3x is going to be underneath the radical. Therefore, it needs to be greater than or equal to 0. In solving that, if we subtract 2 from both sides, 3x has got to be greater than or equal to negative 2. Divide both sides by a negative 3. Remembering to reverse that inequality, so x has to be less than or equal to 2/3. Or from negative infinity to 2/3, including that 2/3. So we're using both of those domains. Because we have the square root, domain has to be from 0 to infinity. And because we have the even-indexed radical, we know that the final answer has to be from negative infinity to 2/3. Good luck on this homework.